Alright guys, welcome on back. This is going to be our review for Test 3, Algebra 1. And we're going to start off with word problems. So we're going to cover 4 different topics here, and we're going to cover word problems, graphing dots and lines, finding y-intercepts, and x-intercepts, and then finding slope. So those 4 topics. Of those 4 topics, finding slope, that last one that I mentioned, we have not gone over yet, so don't stress it that you don't know it. I'm going to go over it in this video. If it doesn't make sense, that's okay. We're going to talk about it in class as well. But it should make sense. It should be fairly simple. Alright, so word problems. We've talked about a lot of different types of word problems in class, but I'm going to be focusing on 2 or 3 main types. Okay? 2 or 3 main types. And I am going to include a couple that aren't on this video, so I'm not going to cover every single one, but I promise I'm going to use these 3 different setups. Okay? So our first problem, let's say it was something like this. So in a given class, in a class, there are 42 kids. All right. And of these 42 kids, there are 12 fewer boys than twice the number of girls. This is actually one step harder than what we did in class, because it is including kind of a double step here, but that's okay. So then I'm going to ask how many girls are there? How many girls are there? Okay, so how many girls are there in this class? Let's go ahead and start working it out, and let's take a look at all of our most important information. And we've talked about a lot of different ways you can approach this. You can do the bucket method, you can plug in numbers that make sense and whatnot, substitute things and values, but we're just going to approach this, and let's figure out what our question is. So remember, our question is how many girls are there? So this is the most important part. So girls, I'm going to represent girls with G. Okay, so I'm going to use the variable G, and you can use X. I know that's a variable I use most often, but I'm going to use G just because it, starts with G. See? All right, so let's go ahead and use G here. So I don't know how many girls there are, but I know that there are girls in the class. Also know that there are boys in the class, but I can't just go plus B. All right, so keep in mind, I cannot just go plus B here, because if I go plus B here, oh my, you can barely see that in pencil. That's why I don't use pencils on these. Okay, anyway, that's fine. I'm going to erase it. So we can't just add plus B, because if we add plus B, now I have 2 variables. And I can't simplify an equation with 2 variables. So we are just going to erase that. And instead, you're going to label your boys in terms of girls. And they gave you all the information you need to do this. So we don't know how many boys there are. But we know that there are 12 fewer boys than twice the number of girls. So let's go ahead and translate that. 12 fewer boys. Fewer, if you look on page 9 in your textbooks, you'll see that fewer is translated to subtraction. This could be 12 less boys. This would be 12 minus 12 boys. The difference between girls and boys. In any case, the words they use matter, and you can just use page 9 if you're not used to them. I would definitely start to memorize that chart. Okay, but 12 fewer boys just kind of makes sense that it would be subtraction. So I know that I'm going to have something subtracted 12. Then twice the number of girls. So it's not just then number of girls, it's twice the number of girls. And twice, if you look again on that chart on page 9, is going to show you this is multiplied. And twice means double, so we're going to do 2 times the number of girls. So let's go ahead and represent 2 times the number of girls. So 2 times girls. And then remember, it's not just twice them, it's 12 fewer than that. So minus 12. So this portion over here is your girls. This portion over here is your boys. And I know that the girls and boys put together equal a whole class of how many kids? That's up at the top. This is at 42 kids up there. Alright, so this whole thing looks like that. This setup is going to be like this every single time, and then now it becomes a basic equation. So before I move on, just a note, on the test you will get a question like this, except what's going to happen is it'll be in a class there are 50 kids and there are 5 fewer boys, then, I don't know, 4 times or quadruple the number of girls, who knows. It's just going to change that number, and then probably this wording or something like that. I haven't entirely decided. Your test is not written yet, but what you're going to do from here is you're going to finish this equation. So we're just going to add and combine things. So let's combine like terms. You've got G, you've got 2G, so G plus 2G is 3G. Remember, combining like terms is a fairly basic process. This is kind of like one girl plus two girls is 3 girls. All right, minus 12. Remember, don't remove the English from mathematics. It absolutely matters. So go ahead, if you need to, replace your letters with things that you know. In this case, I used them to represent girls, so I'm just going to write girls. So 1 girl plus 2 girls equals 3 girls. That should not be a hard concept for you guys by now. Equals 42. All right. And then now let's go ahead and add 12 to both sides. And you'll get 3G, ooh, that's a Y, is equal to 54. And then you'll divide by 3 on both sides. And when you do that, you'll get G is equal to 18. All right. So that's how to solve the equation. That's how to set up the equation. And then there could be one more step, and on the test it'll likely happen where I have 2 types of these questions, where this one goes, how many girls are there? And the second part would go, where's my orange marker? So how many boys are there? And there are multiple ways that you could do this. You could easily know, well, there are 18 girls and 42 in the class total. So if I remove the girls from the class, so 42 minus 18, you'll get your answer. The other way is that you could just plug 18 back into this equation here. So 2 times 18 minus 12. 2 different ways to do it. Doesn't really matter how. I honestly don't care how. That said, if you hadn't figured out G earlier on, then I guess... No, yeah, honestly, neither method matters. So you could get both of these questions on the test, or rather, you will get both of these questions on the test. All right, so that's how to handle that type of word problem. Let's go over one more type of word problem. This one's going to include percentages. So for those of you that don't remember your percentages very well, this will be a brief review of them. I'm not going to talk too much about the many different methods, but you can change your percentages into decimals or into fractions if you feel good about that. Make sure you have a calculator if you plan on using decimals, because I will tell you how far to round. All right, so let's write a question like this. If a number is added to 40% of itself, the sum is 84. And then so find the number. Find number. All right. So given this problem here, if a number is added to 40% of itself, the sum is 84, find the number. In your textbook, you had questions like this, but it was more like there are 2 numbers, one number is 40% of the other number, etc., etc. So they worded it kind of in third person. In like a third person perspective. This one is more like a first person perspective, sort of. There are no I's and me's, but I'm so sorry. Anyway, that's just how I see it. So this problem's worded differently than it is in your textbook, but it's going to be calculated exactly the same. You know you have a number, so as soon as we have a number, this should be something you're very used to by now. Every time you see a number, call it X. We can call it whatever we want. Last time I used G. You can use any letter, but I'm going to use X here. All right. So if a number, so X, is added to 40% of itself, so of, if you look up in your page 9 again, of is going to be that multiply, so 40%. And you can write it like this, of itself. So if they're added together, the sum, so the sum means addition, equals 84. So this is your problem here. And you are going to get numbers like this, so I will do something like if a number is added to 80% of twice itself or something like that. I don't know. And then the sum will be 50. So then we'd have to find that number. But to finish off this problem, there are many ways you can do it. You can look at it like this. You can look at it like this. X plus 0.4, X plus 4 over 10, X. They all equal 84. So all of these are exactly the same. I don't really care how you set it up. with this one, you're going to have to change it to one of these two anyway, unless, of course, your calculator lets you type in percent, which some of them do. It doesn't matter which one you solve. I'm going to do the fraction one because A, I feel more comfortable with fractions, and B, the fractions are easiest to work with without a calculator. So I will teach how to how to do this without a calculator. So this one at the bottom here, x plus 4/10 x. So remember there's like 1 plus 4/10. All right. So 1 plus 4/10 of something is 1 and 4/10 of something of x equals 84. I like pizzas, so let's go with pizza. So it's 1 and 4/10 of a pizza. But here, this is a mixed number, and I told you mixed numbers are kind of hard to work with, so let's go ahead and change it to an improper fraction. 1 times 10 plus 4 is 14 over 10. X equals 84. And let's go ahead and solve this. We're going to divide by 14 over 10. Divide by 14 over 10. And I am going to use this as a bit of a fraction lesson for those of you that don't remember how to divide by a fraction. 84 divided by 14 over 10. This is that keep, change, flip rule. So now x is equal to 84. You know, this marker is really fading. So keep the first value, change the second value, so change it from division to multiplication, and then flip your fraction at the end there. So 10 over 14. And now 84 times 10 is 840 divided by 14. And from here, we just have to do our long division. Let's see, 14 goes into 84. How many times? Here we go. So let's go ahead and do long division out right here. And if you had a calculator, this would be easy as well. But if you had a calculator, honestly, the decimal version of this would be easiest. 14 into 84 goes in, I think, 6 times. Yep, 0 bring down the 0, 14 goes in 0 times, so this is going to be 60. Alright, so x equals 60 here. So if a number is added to 40% of itself, the sum is 84, find the number, your number there would be 60. And again, this is how to do this particular problem. Using fractions, you can use decimals and a calculator, and honestly, it'll probably be pretty quick. So there's that problem. I'm going to go ahead and move it down a little bit so you can see the ending. And then, yeah, feel free to rewind, feel free to pause as much as you need to. And this marker's dying, so we're not going to be using blue anymore for the day. All right. So that's the second kind of problem that you could definitely end up with. Okay? And now, of these two types of problems, and I'm actually going to stick with just these two types of problems after all. I thought I was going to do 3, but that's okay. With these two types of problems, you might get a class. And it could be a different word. So it could be in a class there are these different numbers. And I definitely will have a question like this. I definitely will have a question like this. There will also be another question, which I'm not necessarily going to tell you yet because I haven't entirely built it. But it'll probably be something like you have 2 pieces of string. And one piece of string is 5 inches fewer than twice the inches of the other string or something like that. Twice the length of the other string is probably how I'd word it. In any case, you will get problems, but they're going to use these 2 setups. So if they're percentages, you can set it up like this. If it is just numbers, you can set it up like this. But these are really not all that different. Okay? They follow the same kind of pattern. They follow the same kind of rhythm. So if you can memorize these patterns, you will be fine for this test. So that's going to cover word problems for this test's sake. We're going to do word problem. Well, you're never going to get away from word problems in life. Pretty much every math problem is a word problem. So let's move on to graphing dots and lines. Now, on your test, if you need graph paper to work your problems out, feel free. I will probably include graphs for the problems that I want, but there are going to be problems where you could draw a graph to find your answer, and I'm not going to include that graph, so it's up to you. You could also just rough draw it on scratch paper, however you want to do it. So like you'll notice that I'm not using line paper. I could grab graphing paper, but I just really don't want to. So you can absolutely do all of your work on non-line paper, line paper, graphing paper. It doesn't really matter as long as you do the things that I ask, which is just label your dots and lines. It'll be really, really simple. So graphing dots and lines. First off, on your test, you're definitely going to get a problem that is really, really simple. I'm just going to give you a coordinate plane, and then I'm going to ask you to graph, I don't know, 3, 0, 1, 1, and negative 2, 5. It's going to ask you to graph a couple of dots. So 1, 1, 3, 0, and then negative 2, comma, oh gosh. Well, it'd be up there somewhere. We're just going to do that. So remember, the main thing that you have to remember about this is that your values go in alphabetical order. This is x, comma, y. All right, x comes before y in the alphabet, which is why we graph it like that. So on a given graph, to graph -2, 5, okay, we would have our graph. And we're going to go ahead and draw it out directly. That way I can show you every single step. So 1, 2, 3, 4, 5. And remember, to the right is your x-axis and it's positive. To the left is your x-axis and it's negative. So this was 1, 2, 3, 4, 5. This is -1, -2, -3, -4, and then -5 somewhere out there. Okay? So if the cross is your x-axis, the up and down must be your y-axis. And we're going to also go 1, 2, 3, 4, 5. And then we'll go down -1, -2, -3, oh gosh, -4, -5. And you'll notice that mine is not entirely to scale, so it won't be perfect, but that's okay. Because what you're going to do now is you're going to go, all right, well, -2 is on your x-axis. So remember, your x is this across one. And because it's a -2, we're going to the left. All right, so negative is to the left, positive is to the right. So let's go -2 over. So let's go 1, 2 over. But we're not going to plot a dot here. You don't draw a dot there. You have to still do the other point. You have to do both numbers before you can actually plot your dot. So we went over 2, and then this is a +5, so we have to go up 5. If this were a -5, we'd go down. So we go over 1, 2, up, 1, 2, 3, 4, 5. It's the top of my graph, but it's just because of how I made it. All right. So that was all that was. To graph 3, 0, we'd go over 1, 2, 3, and then we'd go up and down 0. There is nowhere to go, so we're just going to plot our dot. That's it. And then you do the same thing for 1, 1. So 1, and then up 1. Plotting dots, I think everyone got. We did the smiley face exercise and whatnot, so I think you're good with plotting dots. All right. So let's now talk about how to plot lines. And you're definitely going to get this kind of problem. I'm going to give you an equation. Y equals 4x minus 1. Something like that. And I'm going to ask you to... There are going to be two types of questions. I'm going to ask you to either find 3 points on the graph. Alright, and you would use that XY table. We'll talk about that in a second. Or, the other problem could be, or, I don't honestly know, I could have just used orange, but still. So find 3 points on the graph, or graph using at least 3 points. Now, these directions, oh gosh, these directions sound exactly the same. They're pretty much exactly the same, except one is just asking you to give me 3 points. You don't have to graph it. And then this one is actually asking you to graph it. So let's talk about the green one first. So let's find 3 points on the graph, because you actually have to do this to do this one anyway. So to find 3 points on the graph, you make your XY table, and you pick any X's and Y's you want. You can easily use 1, 2, 3, 4, 5, 6, 10, 15, and 20, but smaller numbers are pretty easy, and they're easier to work with, because if you have to graph them, it's really hard, you'll notice, to graph like -80, because that'd be, I don't know, off my paper somewhere that way, so that'd be ridiculous. So you want to keep your numbers small if you can. I'm actually, for this problem, I'm going to use -1, 0, and 1. In class, I think I said 0, 1, and 2 are typically my favorite to use, just because I like that positive sector, but honestly, these are probably the easiest to use in almost every occasion. So let's go ahead and plug them in. So to use this, again, you just pick any 3 numbers you want. Smaller is typically better, okay? But let's find out what we actually do with them. You're going to take your original equation, y is equal to 4x plus 1, and you are going to replace just the x. So y is equal to 4, but not x, okay? Replace it with your first x, -1 here. So instead of x, what you are going to do is you're going to write in parentheses, instead of x, whatever numbers you picked. So start with -1. All right, so 4 times -1 is -4 minus 1, which equals -5. So that means that at -1, y is equal to -5. So let's write -5. Let's do the same thing for 0, okay? So y is equal to 4 times, not x, y is equal to 4 times 0 minus 1. 4 times 0, 4 times 0 is 0, and then subtract 1. And then 0 minus 1 is going to be negative 1. And then you would plug in 1 as well. So 4 times 1 is 4, minus 1 is 3. Okay? And then this is your table of values. Your 3 points, by the way, are negative 1, comma, negative 5. So we had to write our points. Remember, you write your points in coordinate format. So negative 1, comma, negative 5. X always comes before y. 0, comma, negative 1. And then 1, comma, 3. And those are your 3 points for this particular equation. So again, those steps are find any x's you want. I don't care. Pick 3 numbers. Plug them back into your original equation, and then get your y values. Write them in parentheses, and you're all good. Now let's go ahead and graph these. So to graph these, it actually doesn't really require much else. Your first step when graphing is to pick 3 points. Okay? Just like you did earlier, your first step in graphing is to pick 3 points. And we already picked them. I picked negative 1, 0, and 1. And then I plugged them in, and I got these y's. So if you've done this step, this is the next step. I will ask you these separately, so you'll get different graphs. So I will give you y equals 4x minus 1, but then over here I would give you like y is equal to 2x plus 2 or something like that. So it would be a different problem. So you do have to repeat the step, but with different numbers. Okay? But we're going to use the same one for now. So after I've done this whole thing and found my 3 points, all I have to do is graph them. Negative 1, negative 5. So again, negative 1 goes over to the left because that's on the x-axis. And then negative 5 is down on the y-axis. So down 1, 2, 3, 4, 5. And we'll put our first dot. Then 0, comma, negative 1 was our next dot. So 0, down 1. We're going to put it right there. And then 1, comma, 3. So 1. And then 3 is a positive number, so we're going to go up 1, 2, 3. After that, we're just going to draw a line through our dots. Hopefully your lines are straighter than mine. Mine was actually pretty bad, but that's okay. And then all you have to do is label your dots. So let me know that this is 1, comma, 3. Let me know that this is 0, comma, negative 1. And let me know that this is 1, comma, 3. I'm sorry, wow, negative 1, comma, negative 5. Sorry about that. Okay, so just label your points by putting the values right next to that. If you're on graph paper, honestly, this is kind of unnecessary because I'll be able to read your graph, but that's okay. If you just label your points, this is a good habit to get into anyway. Label them by putting the actual values right next to your dots. Okay, so that's how to graph. Again, let's go over that real quickly. Graphing dots, you always go on your x left and right, and then your y up and down. X left and right, y is up and down. And then if you have to find 3 points on the graph, you're given an equation. Pick 3 x's, doesn't matter what x's, and then put them back in the equation. So x, we replaced it with a 0, and then we got negative 1. We replaced it with a negative 1 and got a negative 5. I think I did that negative 1 down here. And then we replaced it with a 1. I did this one in my head, but still. And then you'll get a y. After you get those 3 points to graph it, place the dots, draw a line, label your dots. All right. And that is graphing dots and lines. Let's talk about finding x and y intercepts. This is actually easy. X and y intercepts. In class, this is actually a good way to find 3 points on the graph, but you don't have to worry about that so much right now. Finding x and y intercepts. So, x, comma, y intercepts. All right. So the definition of x and y intercepts is as follows. On a given graph, you're always going to have a line that, crosses somewhere. This line crosses both the x and the y axis. And it crosses the y axis here and the x axis here. Okay? Those are the intersections or intercepts. Okay? In class we compared this to football, and when people make an interception, they cut off a pass. So if this line is a pass, you'll notice that it gets cut off by your y-axis here, and it gets cut off by your x-axis here. So intercepts are literally where the line crosses some other line. Okay? So these two lines cross here, these two lines cross here. To calculate their values is actually fairly simple. So let's give you an equation, something like y is equal to negative 4x. Oh, this is actually really similar to the one we just used, but that's okay. Plus 2. Now this graph, by the way, has nothing to do with this equation because I just made this one up. So this has nothing to do with that. You know what? Actually, let me just go down here. Y is equal to negative 4x plus 2. Alright, so given this equation, let's find our x-intercept and our y-intercept. These two things are defined as follows. The x-intercept is where our y equals 0. And then down here, the y-intercept is where x equals 0. So to solve these, all you have to do is plug in certain numbers. If you want to use the XY chart again, you absolutely could. Basically, you're only going to have two values. If the x-intercept is where y equals 0, and the y-intercept is where x equals 0, you just have to solve the blanks. So there's a blank right here, and there's a blank right here. Let's go ahead and fill them in. Let's test what happens when y equals 0. Okay, let's test what happens when y equals 0. So instead of y is equal to negative 4x plus 2, you're going to rewrite this. Instead of y, we write 0. So 0 is equal to, and then, honestly, I should have written the 0 in a different color. Here, we'll do this. 0 is equal to negative 4x plus 2. So you'll notice that everything in the equation stayed the same except the y, because we're testing it now. So let's test 0. 0 equals negative 4x plus 2. We'll just subtract 2 from both sides. You'll get negative 2 is equal to negative 4x. Then you're going to divide. So divide by negative 4. Divide by negative 4. And a negative 2 divided by negative 4 is a positive 1/2. Alright, so you know now that when y is 0, x is a positive 1/2. Let's do the same thing for the y. To find your y-intercept, we set x equal to 0. So we're going to do the same thing where we rewrite this equation, but we're not going to write x. Instead, we're going to write 0. So y is equal to negative 4 times, not x, but 0 plus 2. And honestly, the y-intercept is a lot easier to find typically in a y equals mx plus b equation, because it's going to make this really easy. Negative 4 times 0, it doesn't matter what this number is, but anything times 0 is 0. Add 2 equals y. And then 0 plus 2 is just 2 equals y. So you'll notice to find your y-intercept, it's almost always going to be this number at the end here. Okay? Typically, if it's in y equals mx plus b form, this is how it's going to work out. On your test, this is how it's going to work out. Alright? So to find your x-intercept, plug in 0 for y. To find your y-intercept, plug in 0 for x. And you'll end up with your two answers. These are your two intercepts. X is equal to 1/2 and y equals 2. And remember, these are dots. Okay? So let's talk about how to graph them real quickly. Shouldn't be too difficult. We have not covered this in class yet, but that's okay. Because what you're going to do is you're going to have a graph. As always, an xy graph. And remember, x goes left, right, y goes up and down. And you're going to graph these two values. So at x equals 1/2, your point, so your actual x-intercept is going to be 1/2. Oh, sorry. On the table is 1/2 comma 0. So again, the actual point looks like this. 1/2 comma 0. And over here, we would have 0 comma 2. So this one's 0 comma 2. What you're going to do on your graph, all right, go ahead and get these together, is you're going to graph those 2 points. What were those 2 points again? So 1/2 comma 0. So let's go out 1, 2, 1, 2, 1, 2, 1, and 2. So 1/2, you'll notice that 1/2 is kind of annoying to graph. So whenever you're having to graph a fraction, if you get a fraction, so if you happen to test values, and I'm going to try to avoid them on the real test, I'm just writing problems randomly, but if you get a fraction for any of your answers, you can graph it by estimate. you know that this is 1/2 on the x, so it's not quite 1, it's halfway there, so we're just going to go halfway. And then 0. We're not going to go up and down at all, so we're just going to graph it right here. That would be about 1/2. Okay? And then over here is 0, 2. So 0, but up 1, 2 spots. Those are your two x and y intercepts. And given your x and y intercept, what you can do is you can now draw a line right through them. And there's your line. All right, and you would want to label your x and y intercepts. So again, that point here was 0, 2. And then this point down here was 1/2, 0. Again, I'm going to try to avoid the ugly numbers. But graphing follows the same rules. As soon as you've done this, you just have to turn it into a point. Remember your XY table. And after you got your points, just graph them, draw a line. You'll notice that this is only 2 points, and then you will have problems that ask for 3. So make sure to follow your directions on the test. All right, that's XY intercepts. Real simple, real easy. One last thing we have to cover. One last thing, and that is slope. Slope and slope formula. Okay, so with slope and slope formula, there are just a couple of things you have to know. First off, we have to talk about the nature of slopes. So there are a few kinds of slopes. 2 special slopes and then 2 kinds of slopes. And they all look like this. So you're either going to have a positive slope. This orange marker feels dead too. Where are my markers? Okay, so a positive slope. You can also have a negative slope. You can have a slope of 0, 0 slope, and you can have an undefined slope. Okay. In class, remember we define slope as the measure of the slanty thing. Okay. Every single, well, not every line, but lines typically have a slant. It doesn't matter if they're going like that. Doesn't matter if they're going like that. Doesn't even matter if they have it going like that. These are all different types of slants. Okay, so the slanty part, the slanty part, slanty part. You'll notice this one doesn't have any slants, so we'll actually talk about that one in a second. But positive slopes go upwards from left to right. So on a given graph, positive slopes go upwards from left to right. They go up from left to right. So every graph we look at from the left side to the right side and follow the line. So here's the beginning of the line, right? And if I follow this line, you'll notice that my marker keeps going upwards on the paper. So that's a positive slope. It doesn't matter if it's barely positive. It doesn't matter if it's extremely positive. Okay. So basically, the bigger your slope is, the more slanty it is. So you'll notice that this one is really slanty, so it has a much bigger slope. This one has a smaller slope. Kind of makes sense. Like if you walk up a hill and the hill is kind of flat like this, you would say, ah, the slope's not that bad. But if you have to walk up a hill that's this slanted, you're going to be really pissed off. Okay, so that's a really high slope. It's a big slope. All right. On the other hand, a negative slope, if you read from left to right, if a positive slope goes upwards, left to right, then a negative slope you would think would go downwards, left to right. And again, negative slopes can also vary. So they can be barely negative. They can be extremely negative. But no matter what, they always go from left to right, your marker goes downwards. Okay? From left to right, your marker or your pen goes downwards. All right? So negative slopes are like down-sloping hills when you have to walk down a hill. And positive slopes are where you have to like walk up a hill. All right? Remember, always from left to right. And then these two special ones, they're a little bit different. But an undefined slope is always going to look like this. It's just a vertical line. This is called undefined because, well, we can't, unfortunately, we can't walk up straight hills. You have to like rock climb that, so it's undefined. All right, so it's any vertical line, it's up and down. So the y-axis, technically the y-axis is also an undefined slope. All right. So it could be any vertical line. It could be way out here, so up and down, way out over here on the left, up and down. It doesn't matter where on the graph it is. It just has to be up and down. So if this one's up and down, you can probably guess, and I kind of mentioned it earlier, this is so this is the x-axis. These are zero slopes. It's when they're perfectly horizontal. And again, it doesn't matter where on the graph. We can go all the way to the bottom of the paper. It really doesn't matter. As long as it's horizontal left and right, this is a zero slope. All right. So again, vertical lines, undefined. Horizontal lines, 0. Negative go downwards from left to right. And then positive go upwards from left to right. These are your 4 kinds of slope. All right. So on your test, what I'm going to do is I'm going to give you a slope or two. So it's going to go numbers 1, 2, 3, 4. I'm just going to do 2, for example. So number 1 will be a slope of 5. And number 2 will be a slope of, I don't know, 5 over 0. Something like that. And what you're going to go is you're going to go, okay, well that is a positive number. So it is a positive or rising slope. Okay, it goes upwards. Positive or rising slope. This over here is over 0, and we cannot divide by 0. So this is an undefined, or negative slope. I'm sorry. Wow. What? It's just undefined. What am I doing? I meant to do the opposite of that, and then I wrote an equation, or I'm sorry, an example that had nothing to do with that. I'm so sorry. So ignore that last little bit. This is just an undefined slope, or vertical, I guess is the other thing you can call it. There. Just so that we have 2 different answers so that it follows a theme. My gosh. All right. Hopefully that wasn't confusing, but you look at the number. If it's positive, then it's a rising slope. If it's negative, then it's a falling slope going down. So negative or falling, positive or rising. Undefined is either undefined or vertical, and 0 slopes are 0 or horizontal. All right. Last thing, let's talk about how to find a slope. Now, we talked about this y equals mx plus b thing earlier, and all of these equations that I've been writing in, so these over here, this follows y equals mx plus b, and we'll talk about what this actually means in a second. The problem before had y equals mx plus, well, this one's minus b. All right. And what this means is that this is your slope-intercept form of a line. So every time you see that format, you know that it's going to form a line. So y equals mx plus b. We've talked about this vaguely, but let's go ahead and go in detail. Your m is your slope, and your b is your y-intercept. Okay? This is why this is called slope-intercept form. I'm not going to write out intercept. I ran out of room. But anyway, this is why it's called slope-intercept form, because it's based off your slope and your y-intercept. All right? So if I give you an equation like y is equal to 3x plus 1, 3 is your slope, and 1 is your y-intercept. Given this information, it's actually really easy to draw, because what you can do is you can go, okay, well, my y-intercept's at 1, so let's plot that dot first. Okay, so y-intercept's at 1. I know that because it has to be on the y-axis, and that's my y-intercept, that 1 right there. So I'm just going to put a dot at 1. And then the slope is 3. Slope is written like this. Slope is rise over run. And you should have heard that in pre-algebra. What that means is that it goes up and over based on this fraction. Remember, all whole numbers can be written as a fraction. So if my slope is 3 over 1, 3 divided by 1 is 3, it rises 3, so let's go up 1, 2, 3, that's a rise, and it's going to run a positive 1, so it's going to run to the right 1 spot. That's my other dot. And then I can just draw my line. If I wanted, I could also have done this in negative format, but that is all this is. So that's what a slope is. What you're going to get on the test is not something like this. On the test, you're going to, first off, you're going to have to explain your slopes. So you do need to know the differences between positive slopes, negative slopes, undefined slopes. and zero slopes or horizontal slopes. Okay, so know these for your test, and then you're going to get questions like this, and you're going to get quite a few of these types of questions. I'll leave that on there while I grab another piece of paper. All right, you're going to get a question like this. What is the slope between the following points? I'm just going to write following, but on the test it'll say following points, and it'll give you 2 points. So number 1, and it'll be point 3 comma 0 and negative 2 comma negative 1, something like that. All right, so these are your 2 points, and there are 2 ways to do this. Actually, you could just graph it, and when there's smaller numbers like this, you can definitely do it. As soon as I give you larger numbers, which by the way on the test I will do, it becomes a little bit harder. But anyway, 1 2 3, and then negative 2 comma negative 1, negative 1, negative 2, negative 1, so right there. And then you can count. So remember, your slope is rise over run, and you can go ahead and go, all right, let's see how far it rose. It rose 1 spot, so it went up 1, and then it went over, so it ran 1 2 3 4 5 over. So your slope is 1 over 5 because it rose 1 spot, and then it ran 1 2 3 4 5 over. If it had gone left, this would be a negative 5, and if it had gone down, this would be a negative 1. But it went up and over. It went, so I'm going to draw the pathing in green here. It went up 1 spot, and then it went over 1 2 3 4 5 spots. Okay? The mathematic way to do this, however, and this is just a formula that you can memorize for the test. Well, honestly, you should probably memorize in general. It's a pretty easy one, and it's useful. Here's slope formula, okay? And you're definitely going to get this. So slope formula is called y2 minus y1 over x2 minus x1. Okay? And let me go ahead and give you an example that'll be a little harder to do on a graph. Actually, no, I'm sorry. We'll use the same exact example. Okay? I know this one would be easier to just graph it and then count that you go up 1 over 5. Some of them it might just always be easier like that, but to use it in this formula, what you'll do is you'll have to name your points. So let's name this left one 0.1 and this right one 0.2. Typically I do that, by the way, because I like to go left to right. In English we read left to right, so it's easiest to put 1 over on the left, 2 to the right. It actually doesn't matter, so if I flip these and called this one 0.2 and this one 0.1, you'd get the same answer. Alright? And what you're going to do, remember this is your x and y. X and y. Every single point has both an x and y. And what you're going to have to do is you're going to say, okay, well this is 0.1, so we'll call that x1, y1. This is 0.2, we'll call that x2 and y2. Now that you have all that labeled, as soon as you labeled your x1, y1, x2, y2, all it is plugging it in. So instead of y2, we'll write negative 1. And then a minus sign. And then y1, so whatever y1 was, which is 0 in this case. And then x2, alright, so let's look at x2 as negative 2. And then minus, so see that minus sign, so we gotta write our minus sign, x1, which is 3. And let's just do the math. Negative 1 minus 0 is just negative 1, over negative 2 minus 3 is negative 5, and a negative divided by a negative is a positive 1 over 5. And you'll notice that they're exactly the same here. Okay? 2 ways to do the same exact kind of problem. You can just graph it and count rise over run, or you can just do your formula. Let's do this with a slightly harder example, because on the test you're going to get something like this. You're going to get negative 10 comma 2 and I don't know, 0.3 comma negative 12. I don't know. That'll work. Doesn't really matter. Now, this kind of problem is still doable on a graph, but it is annoying to have to go, all right, well, here's my graph, and I'm going to go over 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. And you'll notice that you run out of room 7, 8, 9, 10, 11, 12. So it'd be like somewhere up there, and then you know your dot's like way up here. and then -10, so -1, 2, 3, 4, and I'm not going to do it because it's going to get in my space, but -10 would be somewhere out here, and then 2 would be like up here. So this would be way too big a graph, and it just uses too much space. It gets messy, and it's hard to count. So in this case, what I would rather do is just name my points. Let's name this, again, point 1. Actually, we'll name this point 2 just to show you that it doesn't matter, and this one point 1. Does not matter what order. So if I name this point 2, let's call this x2, oh wow, sorry, x2, y2, and then x1, y1. By the way, you notice that I wrote it up here because I'm used to writing exponents, and I scratched it out. Make sure not to write it as an exponent. That is confusing. Write it as a subscript, so this lower number, okay? These are called subscripts. They're just names. They don't have any mathematic value. Instead of a superscript or an exponent, write it down low, and that's called a subscript. All right, and now that we've named everything, let's just go ahead and plug it all in. So y2, our y2 is 2, minus y1. So our y1 is a -12, and you'll notice that we have two negative signs right next to each other, right? We'll talk about what to do with that in a second. And so now let's do x2. So x2 is over here, -10. Don't forget your minus sign. And then x1, 3. So the reason why I keep emphasizing that minus sign is because you can end up with a double negative like this. It happens, so don't lose the minus sign that's already in the problem, okay? It is okay to have two negative signs next to each other, but what happens when we have two negative signs next to each other? You should know by now that they become a plus sign. So the way I do it is that normally I just mark it like this, and I go, all right, well, big plus sign. But if you want, you could just rewrite it again, so it looks prettier. All right, 2 plus 12 is 14, and then -10 minus 3 is -13. So your slope is 14 over -13, which you can write many different ways. You can write this like this, where the negative sign is right across the fraction bar. You could also write it to where your negative sign is on top. It doesn't matter. All these mean the same thing, so it doesn't really matter. All right. We'll talk more about slope in class, but that is how to do slope. So those 4 topics again were, let's see. Okay, so, wait, where are my word problems? Oh, here we go. Okay, so we started off with word problems, that kind of problem, then that kind of problem, and we solved both of them. Feel free to rewind if you needed it. We talked about graphing dots and lines, so just graphing some dots, finding your XY table, and then graphing a line with 3 points. We also talked about X and Y intercepts, and then we also talked about slopes, positive, negative, undefined, 0, and how to use your slopes. How to find your slopes using 2 points. All right. Again, we'll talk about all this in class, but that is all that your test is going to cover. Feel free to rewind. I don't really... that covers pretty much every question type that's going to be on the test. I haven't decided how many there will be, mostly because I don't know how many of these to include. So like when you're just drawing, when you're just telling me if it's a positive slope or if it's undefined, these take all of 2 seconds to write your answer. So there'll probably be a couple of those and a couple of the just plotting random dots. So I'm not entirely sure how long your test is going to be. It is going to be one of your longer longer test questions wise. So you're going to have like 20 questions or something like that, but it will have a lot of these shorter questions where you just have to know how to plot a dot, or you just have to know how to define a slope, that kind of thing. So it'll be questions that are super quick. They will take a couple of seconds that will be on there. In any case, best of luck, happy studying, and have a great rest of your weekend. Bye, guys.